Hi, good afternoon, everyone. This is SID216, Cloud Native App Protection. And my name is Venkat Vijayaraghavan. I'm a product manager on the AWS WAF and AWS Shield team. And with me today is Ian Wright, who is the VP of Infrastructure at Pearson Education. We're really glad to be here today to talk to you about how you can protect your web applications or other custom applications on AWS, and more importantly, hear from customers like Pearson how they have implemented security for their applications on AWS. So very quickly, just to set a quick agenda for the session, I thought it would be good to look at what AWS provides to you to implement that security. And we'll also take a quick sneak peek into how you can protect different types of applications on AWS. But more importantly, I think the big thing that we wanted to talk about today was how other customers like Pearson use those tools that are available on AWS to protect their applications. So with that, let's talk about the 3 pillars of cloud native app protection. But before that, just to set more context of what type of threats are we talking about here. So on a typical application that exists on the internet, you might see a large number of threats. And this is by no means an exhaustive list of those threats, but just some of those really common set of threats that any application faces today. And if you had your applications in your traditional data centers, often you have to deploy firewall devices or appliances in your data center, and you have to scale them and provision bandwidth capacity to mitigate those types of threats, especially in DDoS scenarios, or depending on the type of appliance you're using, you might have to engage your security teams or operations teams in the middle of the night to actually mitigate those threats. And all of that causes a lot of operational burden just to protect some common threats and run simple applications on internet. In AWS, we believe in removing or helping you mitigate some of these undifferentiated heavy lifting and let you focus on building the right set of applications with the right set of security for your applications. With that in mind, we believe there are 3 key pillars that you have to build security for your applications. There is built-in protection that's available for all customers, just because you use AWS. And then in addition to that, there are tools that you can use for customized protection specific to your application's needs. And lastly, there are optional advanced DDoS protection services that you can use to get that up-leveling of DDoS protection and other capabilities around security. And let's look at each one of these, and we'll start with built-in protection. So for some of you might be aware of AWS Shield, and Shield Standard is a service that provides DDoS protection automatically for all AWS customers when you have your applications on AWS. And Shield Standard specifically provides automatic defense against some of the most common layer 3 and 4 attacks, or token transport attacks. And Shield Standard protects you on any internet-facing AWS resource in any AWS region, be it Elastic Load Balancer or the newly released API gateway endpoints and regions, or even EC2 instances for that matter. There are common protections against layer 3 and 4 threats on all these internet-facing services. In addition to that, if you are using CloudFront or Route 53, Shield Standard provides comprehensive defense against all known layer 3 and 4 DDoS attacks automatically, just because you have CloudFront in front of your applications or Route 53 as your DNS. And what I mean by layer 3 and 4 threats are SYN floods and UDP floods and other common reflection vectors. These are really common and easy to generate. And the reason why CloudFront has the comprehensive protection, and CloudFront and Route 53 have this comprehensive protection, is primarily, or one of the primary reasons, is because these are globally distributed edge services. And in addition to that, there are built-in protections in Route 53 and CloudFront. For instance, Route 53 automatically validates DNS headers and drops malicious packets. In addition to that, Shield also performs priority-based traffic shaping based on its prior knowledge of known good versus bad resolvers, and deprioritizing bad resolvers. Similarly, CloudFront and Shield are integrated, and it provides built-in protections for synflets or slow loris attacks, where CloudFront has modules built in that automatically look for open and exhaustive connections and automatically close them, thereby protecting your availability of your applications running behind CloudFront. And because of all these automations built in, over 99% of the attacks, if you're on applications using CloudFront and Route 53, are automatically mitigated today in less than 1 second. And that is really powerful, and that is why we have always said using CloudFront for your applications or APIs is one of the best practices. And just to show some more data around what this has given us or what this gives you, Shield Standard automatically mitigates thousands of attacks on a daily basis. This is just a snapshot of the threat environment dashboard that we recently launched and is available to Shield Advanced customers. This is a view into DDoS attacks across AWS customers. As you see, every hour, AWS mitigates hundreds of attacks, and at least in this snapshot, the trailing 3 days, we have seen over 17,000 attacks, and the largest being 95 gigabits per second or 25 million packets per second. So this is just an indicator that Shield mitigates attacks as we speak, automatically, even without you doing anything. Just to show you an example, Slack is one of the customers who realized this, and they use CloudFront to protect their APIs. Early last year, Slack was looking for DDoS protection for their APIs. But what was more important for them, equally more important for them, was they needed a DDoS provider that is reliable and highly available. They didn't want the DDoS provider to be a single point of failure for their APIs, because availability is super important. And then, of course, Slack uses Classic or elastic load balancers for their APIs. And they wanted to make sure that any DDoS provider or protection that they enable is really easy to integrate with ELBs. Slack enabled CloudFront in front of the ELBs after learning that CloudFront automatically provides some of these built-in protections. And the most important thing that I wanted to convey today is how Slack deployed CloudFront. Slack deployed CloudFront in front of their APIs, which cannot be cached. So Slack simply disabled all caching. So every request went back to their ELBs. And Slack also ensured that all query strings or headers and cookies are not cached as well, and everything is forwarded back to the ELBs. And lastly, Slack terminated TLS at the edge closest to the end client. But that doesn't mean everything from edge to the ELBs go in plain text. They are also encrypted on a different TLS session back to the origin servers. Now, what this gave Slack was, of course, the DDoS protection, because CloudFront is in front of all their API requests. But just as what CloudFront does, this improved their response time significantly. Slack was able to increase the API response time from 488 milliseconds to close to 200 milliseconds. And some of the primary reasons, or at least a couple of the reasons, are, as I said earlier, they terminated TLS at the edge. What that means is that all the three-way handshake now happens over a much shorter round trip between the end client and the edge location closest to the end client. And even though all the traffic, all the requests are being proxied as is back to their ELBs, traffic from CloudFront edge locations to the ELBs went over mostly the AWS backbone network. That means Slack was able to get the benefits of the stable connections and more reliable network, giving them the improved response times. You can learn more about this case study and how Slack went about implementing CloudFront in front of the ELBs in this case study on our website. Now that we talked the built-in protections and how Slack used those, let's talk about tools for customized protections. Very quickly, one of the first tools is, of course, VPC. And I'm sure we are all familiar with what VPC is. I'll probably not spend much time on this, but the most important, and Ian is going to help us understand how this was immensely valuable for Pearson security infrastructure. But one of the things I wanted to call out is security groups, and that allows you to define the ACLs which enforce port restrictions and application restrictions, which we have found to be the most effective DDoS mitigation tools based on our experience operating Shield services. The other tool that's really helpful in protecting your applications is AWS WAF. While security groups help you build those ACLs at layer 3, WAF operates at layer 7 or HTTP layer, and it allows you to defend your applications from web exploits. And with WAF, you can write rules that propagate to all web servers worldwide within less than 50 seconds. Or you can also write flexible rules. You can write regular expression-based rules, or simple IP reputations, or geo-based rules, or even RAID-based rules that automatically block a particular IP when it exceeds a particular threshold. And of course, WAF has full-fledged APIs, allowing you to integrate with your own services that you're using today. You can also integrate with Lambda. We'll talk about that in a minute. And WAF also offers pre-configured CloudFormation templates that you can use to quickly deploy some common protections. We've talked about this in the past. I'll not talk about that again. But one of the things that's new that we launched yesterday is rules for AWS WAF. We're really excited about this capability because this is one of the most frequently asked capabilities from you. And this is a way for you to write or deploy pre-configured rules in front of your applications without you having to write those rules yourself. Managed rules for AWS WAF provides, of course, it's managed, but these, more importantly, these are provided by and written and curated by security vendors who already have provided WAFs over the years and have that expertise in writing or deploying WAFs. In addition to that, with managed rules on AWS WAF, we open it up to the AWS Marketplace. That means you now have the choice of protections. You can choose the type of security vendor you need and the type of protection you need and deploy it on AWS WAF. And you don't have to manage any servers of your own. All of those rules and inspection happens on the managed AWS WAF infrastructure. All you have to do is simply select the rule and deploy it. And all these rules that you subscribe to are automatically kept updated by security vendors as and when they find new vulnerabilities. So you don't have to keep yourself up to date about new threats. And of course, as are other AWS services, managed rules are also pay as you go, and you are charged on an hourly basis for what you use. I won't talk in more detail about how you go and configure, but configuring managed rules is really simple. Simply go to the AWS WAF console. It's available now. Discover the right product or the right vendor, and simply add them to subscribe to them, and simply add it to your AWS WAF environment or the web ACL. And it's automatically propagated in front of all the applications that you have associated this web ACL to. And there is a session focused just on managed rules for AWS WAF later today at 5:45. I encourage you all to go to that session later today. And very quickly, these are the featured sellers that are available on AWS WAF managed rules today. We have AlertLogic, Fortinet, Imperva, Trend Micro, TrustWave, and each of these vendors have multiple products. Some of them have products specific to, say, WordPress and CMS rules. And you can also subscribe to bad IP reputations or bad bot reputations. And there are close to 13 different threat products that are available for you to choose from today. So feel free to go to the AWS WAF console. You can discover all of those right now. eVitamins is one of the customers who used AWS WAF to protect their applications. And eVitamins is an e-commerce site, and one of the challenges they faced was due to availability due to DDoS attacks. And because they were an e-commerce site, they also faced challenges due to bots and crawlers. eVitamins simply implemented the AWS WAF and I wanted to quickly highlight to you some of the rules that they have, which really help them. They easily deployed bad IP reputation lists provided by open source spam house lists or Tor exit nodes. They even deployed some Lambda-based automations that detect bots, some techniques like honeypot-based solutions. And of course, they had also the most common protections like SQL injection, cross-site scripting, which we encourage all customers to deploy automatically. And because of all of these, eVitamins was able to decrease the downtime due to DDoS, because now they have CloudFront that takes care of all the layer 3 and 4 threads, and they have AWS WAF with rate-based rules that automatically block bad IPs that exceed a particular threshold. And most important benefit for them was because of all the automations that they had, where they integrated WAF with AWS Lambda, they were able to considerably decrease the response times to threats. They no longer had to wake up in the middle of the night and engage in mitigation. Mitigations are either already configured or configured to respond immediately because Lambda is automatically looking at it. And there are CloudFormation templates for all of these threats that I just showed you, and you can configure those in just a few minutes. Now let's move on to the third pillar. We talked about the built-in protections and some tools for customized protections and some advanced protection. Shield Advanced is an optional paid service. It's a managed DDoS protection service that provides you additional protections and capabilities in addition to Shield Standard. Specifically, you of course get the additional protection because of the other techniques that Shield Advanced uses, but we'll talk about how DDoS response team, or 24/7 DDoS response team, is something that customers leverage to help mitigate, say, more sophisticated attacks like HTTP floods, where DRT would help triage the attack and write WAF rules on your behalf to mitigate those layer 7 attacks. And you also get the visibility into attacks and cost protection, and AWS WAF is included with Shield Advanced at no additional cost. I won't bore you with all of those. Instead, let's talk about how Netflix uses Shield Advanced and why they use Shield Advanced, more importantly. Netflix uses Shield Advanced for their APIs on ELBs. And there is the good thing about Shield Advanced is that there is no configuration required. So all I can tell you is that it was really easy for Netflix to deploy Shield Advanced on their ELBs because they simply went to the console, or of course the APIs, and chose the ELBs that they want to protect and say, protect me. And because of how easy it is to deploy Shield Advanced without any architectural changes is why Netflix uses Shield Advanced. And in addition to that, the DRT that Shield Advanced provides is integrated with the AWS support that Netflix was already using. And that was a huge benefit for them because triaging an issue is really easy for them. And they don't have to talk to multiple providers to find the root cause and mitigate an attack. Now, just to quickly summarize what we looked at. So this is a typical web application that you might have on EC2 with security groups and application load balancers. And as we talked about, you can deploy CloudFront in front of these applications and protect them against DDoS attacks. And there are built-in protections with CloudFront, like SYN-FLET protections and LRS protections, that give you comprehensive protections against these layer 3 and 4 attacks. Route 3 also provides you similar protections against several of these layer 3 and 4 attacks. We also saw how you can use AWS WAF, and more specifically, you can use the managed rules on AWS WAF, or even customize AWS WAF for your own applications. And lastly, we saw how Shield Advanced is something that you can optionally enable and make use of that managed DDoS protection and access to DDoS response team, and if you like, the visibility into attacks on your applications as well as AWS-wide applications. But what about custom applications? Because all the things that I talked about used services like CloudFront and ALBs. CloudFront only accepts HTTP traffic today. Now, there are a lot of customers today who run their say, game servers on EC2. Game servers primarily run on UDP, and there are other UDP-based applications like voice applications or even file transfer applications. So how do you protect those? So we just want to quickly touch upon protecting non-web applications as well. So as I said, for a non-web application, say something running on UDP, you typically have to run it on EC2. You won't be able to use ALBs or CloudFront. Now, in those cases, one of the really helpful tools is the security groups. And as I said earlier, enforcing ACLs and blocking ports that you don't expect traffic from or blocking other suspicious ports are some of the most effective tools or mitigations that we have seen on AWS Shield based on our experience. Now, in addition to that, of course, there is Shield standard, as I talked about earlier. Shield standard, as I said, is in front of all internet-facing AWS services, including EC2. Shield standard automatically provides you defense against some of these most common layer 3 and 4 attacks on EC2 as well. The way Shield standard does that is it uses priority-based traffic shaping. Based on heuristics collected across AWS customers, we have gathered data to understand what type of protocols are and what type of protocols assume what volume of traffic. And say, for instance, traffic from suspicious UDP ports exceed, say, several gigs of traffic. That is suspicious, and we put that in a lower priority queue. Similarly, traffic from, say, less common protocols like SNMP or NTP should not, any particular instance should not receive several hundred gigs of traffic on those. So we give those a smaller shape. And by doing this priority-based shaping, we are able to ensure that we can deliver the right volumes of traffic and the right types of traffic to your EC2 instances. Now, in addition to that, last week, we launched Shield Advanced for elastic IP addresses. Until now, or until then, Shield Advanced was available on CloudFront or ELBs or Route 53, which, as I said earlier, is primarily for web applications. Now you have Shield Advanced for elastic IP addresses. This means you can enable advanced protection on an EIP, which can be attached to an EC2 instance. So the architecture looks pretty simple. You have an EIP attached to an EC2 instance, and simply enable Shield Advanced on it. Now, very quickly, Shield Advanced for elastic IP provides you improved detection capabilities. Shield Advanced, when you enable Shield Advanced on an EIP, Shield Advanced automatically discovers the type of EC2 instance and the size of EC2 instance, or even if you had attached that EIP, say, to a network load balancer, it still detects the type of AWS resource behind it and applies detection techniques specific to that particular resource. And as soon as Shield detects a threat, mitigations are enforced automatically. With Shield Advanced on EIPs, there are new mitigations that we have deployed specifically for EIPs. There are new mitigations for SYN floods, which are a lot harder to mitigate on an EC2 instance as compared to something like a proxy like ELB or CloudFront. With Shield Advanced for EIP, we also automatically propagate the network ACLs that are currently running on your VPC out to the border of the AWS network. What this means is that you now get that scrubbing capacity and the bandwidth capacity available at the AWS border as opposed to something that's available on your VPC, thereby allowing us to mitigate large volumes of attacks. And again, just to reiterate, ACLs are one of the most very useful techniques to mitigate these attacks. And that's why that's one of the key things that we did for Shield Advanced for EIPs. And in addition to that, you can also define custom mitigation profiles working with the DDoS response team. Here, custom mitigation profiles are mitigations like, for instance, let's say that you have your applications and you know that there are some trusted clients or trusted IPs or trusted customers who you want to give a preferential treatment, or maybe you only see traffic from these known sources. You can define a mitigation profile that says these are the trusted clients, and always give them a higher priority during a DDoS attack. And everyone else is put in a lower bucket or a lower queue with a lower priority. That's just one. And similarly, you can prioritize traffic by geos. And if you want to prioritize traffic specific to a particular geo, you could apply a custom mitigations or custom traffic shaping for that. And of course, just like we do today, you also get the benefit of traffic engineering, where we can ingress traffic not just on the transit center where your services live or where your EC2 instances live, but use traffic engineering to ingress traffic from across the AWS network to give you access to larger bandwidth capacity and scrubbing capacity. And then, of course, just like Shield Advanced does today, you get that visibility into attacks. You get instant notifications via CloudWatch metrics, which you can use to alarm or trigger your own SOC teams and or automatically perform an automated response to it. In addition to that, very recently, we also started providing attack details that give you more details about the attack, not just the notification, but also details about what type of attack it was. And more importantly, what are the source IPs, and what are the top talkers during the attack, and what are the top geos or ASNs during the attack. And similar protections or similar visibility is also available for layer 7 attacks as well. Okay. Now to quickly summarize what we looked at, we talked about built-in protections and how Slack uses some of those built-in protections, and they got those by simply deploying CloudFront as more of a DDoS proxy. And because CloudFront was in front of all their requests, that gave them fundamentally more resiliency against DDoS attacks while keeping the high availability that they wanted and also decreasing response times. Then we talked about eVitamins and how eVitamins uses AWS WAF to build customized protections. eVitamins also, of course, uses CloudFront, so they get all the same benefits. But in addition to that, they also have AWS WAF rules to block bad IPs that should never be hitting their applications in the first place, or deploy rate-based rules that automatically block a particular bad IP sending large volumes of traffic, and also some bot protection techniques. And in addition to that, if you want to try AWS WAF, you can also use the newly launched managed rules on AWS WAF. And lastly, we also saw how Netflix uses Shield Advanced to protect their ELBs, and how it's really simple to deploy Shield Advanced, and how they got the benefit of DDoS response team, which is integrated with the AWS support team. So with that, these are the 3 use cases I talked about. Now I would like to hope you can hear from Pearson as to how AWS helped them protect against DDoS attacks for their applications on AWS.
Hi, good afternoon. So just a quick overview about Pearson. So we're most of you may have heard of us. We're an education company. We have everything from K through 12, through higher education, through professional education. Today we're going to focus a little bit more on the high-stake assessment world. And so just go over some of the challenges that we faced early days. So like most big enterprises, we were sitting in traditional data centers. 2015 was an interesting year. We had a number of DDoS attacks that impacted us on the data center front. We implemented a number of remediations for that. We put in DDoS appliances, we put in IPS, IDS, increased the size of our load balancers, and really struggled. We had a number of attacks that took our infrastructure down. We added the cloud service provider protections. We routed on with a cloud service provider to provide the protection side of things. So the biggest challenge we faced was that we had a number of attacks, and we exhausted our internal infrastructure. So attack would hit. We couldn't scale out of the attack. The infrastructure we had within the data center wasn't enough to get us out of that attack. And so we looked towards Amazon. So we started with the DDoS protection with Amazon, and we followed their best practices. And so we looked at a few things here: minimize the surface attack area, scale to absorb the attack, safeguard our exposed resources, and baseline normal behavior. So on the surface attack area, we took advantage of a couple of things. So VPC, as most of you will know, allows you to hide most of your public or your assets behind in a safe environment. We utilized elastic load balancers, and we'll talk about both of these a little more. So with the VPC, hiding our instances from the internet, we minimized the public entry points into our assessment platforms. And then we utilized our security groups and network ACLs to control the inbound and outbound traffic. ELB, we started our AWS journey about 6 years ago. Started on ELB 1. We had our EC2 instances behind a single ELB tier. We all scaled to handle fluctuations. And we had several DDoS protections built into the ELBs from Amazon. Early days, those of you that were on the private preview with Amazon and went into the DDoS protection service will remember the little emails you got. So every week you'd get a little email saying, we didn't see any notable attacks on your infrastructure. Moving along. So DDoS attacks are mostly, not all about, but mostly about scale. Biggest challenges we have is when the application can't accommodate the traffic that's being driven by those attacks. And so we needed an architecture that could potentially scale out to absorb that attack. So instance scaling, being able to rapidly scale independently within our service tiers, being able to add additional memory, CPU, capacity on demand, auto scaling, and scaling out. And then one of the biggest benefits that we saw was adopting the CloudFront, putting CloudFront in front of all of our applications, allowing that to do our caching for us, and scaling beyond what our actual applications could do. So obviously not all of our resources can be behind the boundaries of the VPC, so we need to protect our public entry points and safeguard those entry points. And so CloudFront, a few of the things we did, so we required CloudFront for all of our applications, lower latency from that and improved performance. From a CloudFront perspective, it automatically filters the malicious traffic. And Jira restrictions. So if you look at the, we do a lot of high-stakes testing. And so if you look in the US, we test about 50, and Brendan, correct me in the audience there if I'm wrong, but about 50 million high-stakes assessments a year. And we can have anywhere from 500,000 to 1 million students testing at any given time. And so that is very US-centric. And so we don't have students in Russia testing within the US high-stakes testing platforms. We don't have students in China. And so Jira restriction is really something easy that we can put a switch on and say, hey, we don't any traffic coming from outside the US, we don't want to see it. So, and then one of the Amazon best practices is to restrict VPC-only traffic from CloudFront as well. From a WAF perspective, interesting example, which I'll give in just a minute, but we adopted WAF. WAF allows you to block common exploits, cross-site scripting, SQL injections, HTTP level inspection, and so forth. But a good example that I'll give here is that we had one of our products, which most of you remember the Apache Struts vulnerability. And this particular product wasn't protected by WAF. It was sitting on early days ELB1 infrastructure. So we talked to our development teams, and they gave us an estimate. Time to remediate was about 2 weeks. Like I said, using ELB, early day ELBs. And so the infrastructure teams migrated those ELBs to ALBs pretty much overnight. And we were immediately able to block the vulnerability using a simple AWS WAF rule. Something else that we focus on is baselining. So one of the things that we try and do across all the product lines that we support is baseline normal behavior. So what does normal look like across all of our applications? Basic up-down monitoring. We get a real-time view of what the applications look like, look at what the traffic looks like, look at what the normal high peaks and low peaks look like. And we mine data from a number of different sources, real-time monitoring of deviations, and have a pretty good engineering organization that is engaged for any triaging. So baselining techniques that we use, daily benchmarks, alerts configured on deviations, automated response, engaged engineers, and then the metrics we monitor, a few of them, CPU utilization, flow logs, application traffic, web server logs, and so forth. We have an interesting structure within our organization. We have a three-tier engineering group. So we have an operations center, we have a DevOps organization, we have a SRE organization, and baselining is a responsibility that spans all three of those organizations. And that, I think, is that.